Alright guys, so we're still working on our exponent rules. So looking at the first section with the 1 through 28, we're multiplying powers. Remember that when we multiply powers, that means that we're going to add the exponents. So, for example, number 1, 5 to the 9th times 5 to the 3rd. That's really going to end up being 5 to the 9 plus 3. That ends up being 5 to the 12th power. Okay? Number 2, when we don't see an exponent, we have to know that that exponent is a 1. So that gives us 3 to the 8th power times 3 to the 1st. We're going to go 8 plus 1, and that's going to give you your answer. And so you're going to finish that one up. Number 3. Looking at this one, c to the 1st power. So looking at it, we're going to go c to the 1st plus 6. That's going to end up with c to the 7th power. Okay. Number 4. Okay. You have m to the 5th times m to the 2nd. I want you to go ahead and do that one on your own. Number 5, we start having coefficients in our expressions. So let's break it apart. We have 3 times x to the 1st. Remember, when we don't see the exponent, it's to the 1st power. Times 4 times x to the 4th. 3 times 4 is 12. Then we have x to the 1st plus 4th. And that's going to simplify to give us x to the 5th power. Number 6, we're doing the same thing. We have all of this together. We're multiplying those things out. So we have our 2 times 7. Okay? So we have 2 times h to the 7th times 7 times h. Because with multiplication, remember that it's okay that we break it apart like that. Okay, so we're going to take our 2 times 7 is 14 times h to the 7 plus 1. And then that will give you your answer. Number 7, when we break it apart, we have negative 5 times d to the 6 times 8 times d to the 6. Negative 5 times 8 is negative 40. And then d to the 6 plus 6. That gives us negative 40. D to the 12th. Okay, number 8. Breaking it apart, we have 6 times k to the 5th. There is not a coefficient written in front of our k. So we're going to treat it, it's a negative 1. So times negative 1 times k to the 4th. So 6 times negative 1 is negative 6. And then k to the 5th plus 4th. And that's going to end up giving us negative 6 times k to the 9th power. Number 9. Let's get it set up, and then you can finish it up. Number 9, we have that coefficient. Even though we don't see it, we have that negative 1 times w times, I'm going to put that negative 10 in parentheses to make sure that that negative is hugged to the number, times w to the 3rd power. Negative 1 times negative 10, negative times a negative, going to give us a positive. So go ahead and finish that one up. Number 10, breaking it apart. Negative 7 times z to the 4th times negative 3 times z to the 8th. Okay, multiplying your coefficients. Negative 7 times negative 3. Again, we have a negative times a negative, and that'll give you a positive. And so you're going to go ahead and finish up number 10. Number 11, breaking it apart. B times c to the 3rd times b squared times c. Remember, when we don't see the exponent, it's automatically to the first power. It's the invisible first power. We can't see it, so we just have to know it's there. Okay, so go ahead and simplify number 11. Number 12, breaking it apart. 3 times a to the 4th times 6 times a to the 2nd. Okay, and then I want you to go ahead and finish looking at 13, 14, all the way through 16. Those are really a review from the our last night's homework too. Looking at the next section, we're dividing powers. When you divide powers, you subtract. Guys, notice that it is opposite for multiply. When you multiply powers, you add the exponents. When you're dividing powers, you subtract exponents. So it's the inverse, which makes a lot of sense. Okay? So let's look at number 17. I can look at this and I'm going to write it out and expand it. So 2 to the 9th means 2 times 2 times 2 times 2 times 2 times 2 times 2. Okay, so that's 9 2's. And on the bottom I have 2 times 2 times 2. Okay, so thinking this one through, if I simplify this, I know that 2 divided by 2 is going to give me 1, so those can cancel out. 2 divided by 2 gives me 1. 2 divided by 2 gives me 1. And then that leaves me with this answer right here. That gives me 1, 2, 3, 4, 5, 6 2's. So that means that my answer is 2 to the 6th power. Guys, if it helps you to expand that out, you can absolutely expand it that way. Now, using our rule, the way that we would do it is that we would go 2 to the 9 minus 3, and that equals our 2 to the 6th. Okay, looking at number 18, 3 to the 8th over 3 to the 4th. Okay, so using our rule, that's going to end up being 3 to the 8th minus 4. So that leaves us with 3 to the 4th. Okay, go ahead and do 19 on your own. Number 20. Okay, remember when we don't see an exponent, we know it's 1. So that is 8 to the 7th minus 1. Okay, and so that will give you your final answer there. Okay, number 21, go ahead and work that one out on your own. Number 22, let's look at it. So we have 12 times n to the 5th divided by 4 times n to the 2nd. So if I expand this out, I have 12 times n times n times n times n times n, all over 4 times n times n. Okay? So if I start simplifying this, I know that n divided by n gives me 1, so they go away. N divided by n gives me 1. So I have these 3 n's, and then I have 12 divided by 4. Okay? Well, that's going to simplify. 12 divided by 4, that ends up giving me 3. So all of that ends up equaling 3 n to the 3rd power. Now, let's look at it using our rule. Okay? So we would have n to the 5 minus 2, but then we also have that 12 divided by 4 is 3. And so that simplifies to 3n to the 3rd power. Okay? Number 23, we're going to work through it the same way. Okay? That 14 divided by 7 gives us 2. Then we have m to the 3rd minus 2, which equals 2m to the 1st power. Okay? So I could put that 1 there, but I don't need it. Okay? It just m means to the 1st power. Okay? 24, same way. Okay? So looking through, you're going to go ahead and do the same thing all the way through 26. Let's look at our next one. Okay, look at number 27. With 27, you're still following our exponent rule with dividing powers, but we're going to go through just taking terms that are like terms because the base has to be the same. So a to the fourth and a squared. So I'm going to have that a to the fourth minus 2. C to the sixth over c to the first. So that ends up being c to the sixth minus 1. When that simplifies, we end up with a squared and then c to the fifth. And that finishes up our first side. Okay, so looking at the back side, I'm going to go over a couple of them from the top, but this is a review of multiplying or having a power to a power. When we do a power to a power, that means that we are going to multiply the powers together, because with number 1, remember that when we have this third power right here, that means that we are multiplying 7 squared to itself 3 times. So when we think about our multiplying powers rule, that would end up being 7, 2 plus 2 plus 2 gives me 6. Now, with our rule that we are learning, we have 7 to the 2 times 3, and that gives us 7 to the 6th power. So that's what you're going to be doing on this section. Okay, so number 2, 3 to the 2 times 6, and that will get your answer. Try number 3 and 4 on your own. Number 5, d to the 7 times 6. Okay, when you multiply 7 times 6, that ends up with d to the 42nd power. Okay, you're going to go ahead and finish up 6, 7, and 8 on your own. Looking at number 9. Okay, power to a power to a power. We're going to just work through step by step. So 4 to the 3rd times 2. Okay, and then all of that is still raised to the 2nd power. So that gives us 4 to the 6th on the inside, 2. Now we're going to do our step one more time. 6 times 2 gives us 12. So we end up with 4 to the 12th power. Now let's go ahead and move on to looking at number 12. It's going to be the same thing. So I want you to go ahead and do number 12 on your own. Number 17. Okay, we need to, on number 17, express the area of each square below as a monomial. Okay, so monomial is just a fancy word that meant just talking about the term. So right here we know how long this side is. Remember that area of a square equals s times s, or area equals s squared. Okay, so if this side equals 6g to the 3rd times h to the 5th, then this is going to equal 6g to the 3rd, h to the 5th. So that means that if area is going to equal 6g to the 3rd, h to the 5th, all of this raised to the, I don't know why I put the wrong exponent, but it's all raised to the 2nd power. So we're going to go through and we're going to apply that rule to all of our terms. So we have 6 to the 1st, so that'll be 1 times 2. Then we have g to the 3rd, so that'll be 3 times 2. Then we have h to the 5th, and so that'll make it 5 times 2. And all of that, when we simplify it, is going to give us the area of our square. Okay, so when you finish that, you will have it all finished. All right.